get the proper explanation for the solutions. Okay, let's move on to the next topic. My dear students, this unit 8 is very important, mainly because when you go to the plus 2 class 12, you can see that the whole volume contains only the organic chemistry part, and this unit specifically gives the very fundamental or very basics for understanding the organic chemistry. So I suggest you to go through this specific unit again and again, so that you can understand the things completely, because without understanding this unit you will not be able to uh, achieve anything in the class 12 volume 2. Okay, so now we are coming to an important section where we are going to study about the structural representations, because many of the times we will get confused by the structures given in the question paper or the books. Okay, so basically whatever structures we write, they are all derivation of the Lewis dot structures. Okay, from the Lewis dot structure we simply add a dash between the atoms, so we get the bonds. Okay, which we call them as a bond, and we understand that by entering a dash there are two electrons, which indicate that is a covalent bond. Okay, so there are three types of structural representations. First one is complete representation. Second one is condensed representation. Third one is structural formula. Sorry, bond line structural formula. Okay, complete representation, then condensed representation, then bond line representation or bond line structural formulas. I will start with the fundamental structures. Okay, let's see for methane. Okay, methane we write like this. This is a molecular formula. Let's say you can write down in your notebook like this, so that you can have a comparative idea on how you can write the same molecule in a different way. Okay, so this is methane, and the complete representation of this molecule is like this. You have to write all the atoms with the dashes. These dashes indicate that there are two electrons shared between the central atom carbon as well uh, as the hydrogen atoms. Okay, so let's go to the next one. Condensed structure. In condensed structure we simply write the molecular formula. Okay, very simple, we write the molecular formula except where there is a branches. We will see those examples also. Okay, in bond line structure there is no bond line structure for methane. Okay, let's go to the next molecule, ethane. Okay, ethane we can write like C2H6. How to write the complete representation? There are two carbon atoms. First you have to write the carbon atoms, then you write the number of hydrogen atoms. There are three, right, on the right side, and there are three on the left side. This is the complete representation. When it comes to condensed representation, you can write this molecule as CH3 CH3, right? This is a molecular formula, and this is the condensed formula, condensed structure. And how to write the bond line structure? Okay, bond line structure for ethane is very simple. uh, Write a simple dash. Okay, simple, very simple, you write a dash Whenever you write a dash, it means that there are CH3 at each end. Okay, only in chemistry you have meanings for single dash and double dash and triple dash. In this case, it's a sigma bond where you have two methyl molecules. In the case of two dashes, it means it's a double bond where we say there are two CH2s. When you see a triple bond or triple dashes, it's nothing but the ethane. Okay, I think you get the point, right? So this kind of representation is possible. This is called as bond line structure. Okay, let's try to write that again. All right, so bond line structure for ethane is a simple dash, right? So let's look at one more example. um, C3H10. Okay, this is a propane. Some of the examples I am giving you are not available in your books, but these are all fundamentals so that you can easily understand, right? First you write the number of carbons like this, then write the hydrogens. Remember that carbon has four valencies, so you should count one, two, one, two, three, four. Okay, you should know there are four valencies, right? So this is the complete representation of propane. Okay, what is the condensed structure? CH3, CH2, CH3. This is the condensed structure. What is the bond line structure? Very simple. I said that when you write like this, both ends have CH3, CH3. How to write the CH2? Very simple. Just make a V shape. V shape, that's all. This means that this is equal to CH3, CH2, CH3. Okay, and this one is equal to CH3, CH3. So when you write any reactions in the examination, never ever make a mistake to put a dash like this or any triangle like this. You will end up with not getting any marks. Okay, be careful because even the dash has a meaning in the chemistry, organic chemistry, right? So I think these things you understand. Okay, let's go for one more example. Okay, out of the book, let's go for one more example. Um, let's say C4H12. Okay, so there are four carbons, right? C, C, C. I will write like this, C. Okay, there is a branch. Okay, so H, H, H. Here is a hydrogen atom. Here is a hydrogen atom, hydrogen atom, hydrogen atom, and this carbon will have three hydrogen atoms, right? So how many carbons are there? One, two, three, four. So four carbons are satisfied. How many hydrogens are there? Here is a 3, here is a 3, here is a 3. So 9 and then 10. Okay. So this is not a 12, this is a 10, right? So how to write in a condensed form? CH3, CH, CH3, CH3. right? So this kind of structure you can write. Okay, so this is called as 2-methyl propane. The naming part we will discuss in the next videos, upcoming videos. Okay, you can simply know, or you can simply learn how to write the full structures. Now let's come to the point how to write this as a bond line structure. Okay, so we will make like this one. Okay, this is for counting for three carbons, right? Here one carbon, here one carbon, here one carbon. And how about the third one? You can simply write like this. That's all. You can write in any way. Even you can write like this also, no issues. Still you are counting with four carbons, no problem about that. Whatever the direction you can write, no issues for this carbon, for this carbon specifically. Okay, so I believe this gives a fair idea for you how, what are the different types of structural representations. These are all called as molecular formulas. This is called as complete representation, where you write the complete structure, each and every detail. There will be a single bond, there will be a hydrogen atom, like that. You have to write each and everything. In condensed form, you will write the as a molecule. Okay, this is a methyl group, this is a methyl group, and you can write like this. Okay, and when you see a branch, you have to indicate it by a bond. You have to keep these rules in your mind. Okay, and when we write the bond line structure, it is quite easier. In most of the books, in your exams also, in most cases, you will follow the condensed structure or bond line structure. Okay, you will follow the complete representation whenever there is a need for explaining the reaction mechanism, which we will discuss at the end of this unit. Okay, so always you go with the content structure or bond line structure, whichever is easier for you to understand, that you can follow, no issues about that in the examination also. Okay, now let's discuss about how to draw the cyclic compound structure. Okay, let's imagine we have a cyclopropanone. Okay, cyclopropane. How to write this in the bond line structure? Very simple. Draw a triangle. It's more than sufficient. Even for the cyclobutane. Okay, this is cyclopropane. This is cyclobutane. This is equal to, this is not a triple bond. I am saying it is similar, equal to, okay, square. You can write like this. As I said earlier, even a dash, double dash, triple dash, triangle, square, hexagon, everything has a meaning in organic chemistry. And how about a pentane, cyclopentane? Remember that when you write this one, CH2, you can, this is the actual way to write. This is the original way to write. But in your textbooks or sometimes in your examinations, if you write like this also, it is accepted. There is nothing wrong. But still, you follow the standard structure like this. Okay. All right. So let's try to write the cyclopentane. How to write this one? Very simple. Write a pentagon, right? How about a cyclo or chlorocyclohexane? Let's say we have a structure like this. Okay, Okay, CH2, this one CH2, this one CH2, and there is a bond. Okay, there are six carbons and this one CHCl. Let's imagine there is a chlorine molecule. How to write this? First you draw a hexane, a perfect hexane, all sides are same, a perfect hexane. Then you draw the branch and then you write the functional group. This is called a functional group. Okay, so you can write like this. And there are some more example problems given in your book. You can follow other videos in our channel to understand how they are written. Okay, so next let's move on to three-dimensional representation of organic molecules. Okay, how the organic molecules are represented in three-dimensional way. You first there are certain things we have to understand. Okay, for example, when we write chemicals like this, when we write chemicals like this, you may think that for example, okay, let's say here, right? When we write like this, you may imagine that all the carbon and hydrogen atoms are on the same plane, I mean on your screen. But in reality, they don't exist like this. Even when you write the complete structure for this ethane, these atoms do not fall in the same plane. Okay, there are several reasons, starting from steric hindrance to other reasons like lone pairs and others, and bond angles, bond lengths, they all are important. Okay, so how to represent a molecule in a three-dimensional manner? We always tend to imagine how a organic molecule can exist in nature. Okay, x-axis, y-axis, and z-axis, how they can exist. Not like this one. This is a two-dimensional representation we write for our understanding. Okay, so how to write them? We understand that carbon has four valency, right? The four valencies are written as tetrahedral. Okay, and this is not the exact way it exists in nature. How it exists, that's the biggest question, right? Let's imagine we have methane. How the hydrogen atoms are placed in three-dimensional space. Carbon, there will be one hydrogen, there will be other hydrogen, and there will be the third hydrogen, which is towards the observer in the sense yourself. Okay, that is indicated by a solid wedge. This is called a solid wedge. This kind of representation is called a solid wedge. And there will be one more molecule, which one more atom, which is indicated by the dashed wedge. Okay, this one is away from you, and this one is towards you. That means what I'm trying to say is these three atoms are exactly on your screen, your laptop, your mobile phone, your tab, whatever mode you are watching on. These three atoms are on the screen. Simply they are in the same plane. And this hydrogen, if you put a pen on the carbon atom vertically, it will be, the pen's top portion will be towards your face, right? That's how exactly this hydrogen exists. Okay, perpendicular to the plane, perpendicular to this plane. Okay, and this hydrogen exists in exactly opposite to this hydrogen. Okay, so this hydrogen is also in 90-degree position, exactly opposite. Okay, let's imagine you have a pen or pencil placed on this carbon behind the screen, whatever the device you use, it may be laptop, mobile, or tab. Just imagine you have this carbon, you place the pencil or pen behind the screen on this carbon. That is where this hydrogen is available, and this hydrogen is available in front of the screen. Okay, so this hydrogen is called as towards yourself or towards the observer, and this one is away from the observer. Okay, this is how we represent the organic molecules in three-dimensional space. Earlier days, people had several models to understand the reactions, like they would like to draw structures like this kind of sticks. This kind of things are called as framework model. And there were scientists where they have the balls which indicate the atom. Usually the carbon atom will be a little larger, and there will be a stick to attach with the smaller atom, which is usually hydrogen. Okay, this kind of atoms also, this kind of representation also available. This is called as ball stick model. And there are some other models which where you have the ball similar to the previous one, ball and stick, and the other atoms are simply attached on it. Okay, they won't indicate the bond by the this kind of stick. Okay, this is called as space filling model. Okay, so this kind of representations are possible for you to write the organic molecule in three-dimensional space. Okay, so with this we will end this lecture. In the next video, let's discuss about the classification of organic compounds. You can go through the video one more time to get understanding on how to write the basic structure, and you also go through our other videos on the solutions for the example problems given in your book. Okay, take care, see you in next video.